Okay, hi everyone. I'm actually going to switch off the camera because it does seem to affect the efficiency of the broadcast. So let me just do that. I have a couple of scripts to show you. This is really for the students, again, doing their first showreel and maybe wanting to show some CG. Of course, it's not the most the most important of the skills. You know, when you are starting up, if you are doing if you are going for rotor prep jobs, but certainly something that you would want to you know, be able to show in some sort of form. I actually have two showreels again. I can show you later to show you the sort of examples of the work that people finishing our courses would put on a showreel, especially the CG elements. Now, there are many reasons we don't deliver the final shots as they are rendered from CG. I think the most important ones are flexibility, being able to, you know, allow for all sorts of changes and for efficiency. So we can make adjustments very quickly without the need of extensive rendering in CG. At the moment, I just have this underwater drone on screen. We'll just have a look at this script in a minute. The reason we wouldn't put something like this straight just onto what we call a beauty render, we wouldn't put it straight onto, let's say, the live action shot or whatever background we have planned for it. But we would want CG to provide us with AOVs, which we'll go through in a minute as well, so that we have much more flexibility in, you know, in case we want to do changes. And also, there are aspects of CG renders that are especially render heavy, like depth of field, denoising, motion blur, and we can add all these quickly and pretty accurately in 2D. So that's particularly relevant if we are compositing into live action plate and want to have, you know, control over grading and even have access to masking and so on. So these days, of course, those of you, and I'm sure you are using Nuke, but even if you are using Fusion or Flame, we have certain access of to 3D in compositing softwares like those. And we can utilize projections and relieve some tasks from 3D, some tasks that traditionally they had to do. So the benefit to compositors is that, you know, the final look of CG is left to us, really. You know, it means that an efficient pipeline between CG artists and compositing artists, of course, is very, very important. So when CG renders a beauty pass, like in this case, this drone we are looking at, this is just a demonstration script, one of the scripts we use in our courses, in all the courses, UG and short courses, and masters as well, to really show the Arnold passes, because Arnold is actually the renderer we use the most for photorealistic compositing. So when CG create a beauty pass like this is what we will call the beauty pass. They've already gone through an approved process by the client, whoever is, you know, in commercials, it will be a director or ultimate client. In film, it would be, again, director, producer, studio. You know, there is quite a big hierarchy in the approval process. But in any case, this would be an approved element. So the client has approved the model, the shading, texturing, lighting, animation, everything. So we could effectively, you know, comp this beauty pass, and we do sometimes. we could comp it onto the background and not actually AOVs. So at the moment I can't share the screen, but Still, I'll just talk about a few things. I didn't notice exactly when we lost each other. So what I wanted to say is that when CG renders a beauty pass, it means that that beauty pass has already gone through the approval process. So the client has approved different stages of CG. For example, obviously the model, the animation, the lighting, any texturing and so on. So sometimes, and in low budget productions, of course, we can just comp that over the background, okay, I still can't screen share. No problem, I'll just wait to screen share. But as I said, we can just, on some low budget or at the very end, even of high-end productions, sometimes we'll just, comp the beauty onto the background and just make a few adjustments, let's say with grading, defocus, and maybe some other filters. But normally we would comp. And I just wanted to show you comp different AOVs. I have few things to show you. So as soon as I am able to share the screen, we'll continue. Do
you want to try it now, Klaudija?
Okay. Okay, so now I can, just a second. So I'm just gonna show you a couple of things. First of all, as I mentioned already, normally we use, most of the time these days for photorealistic compositing, CG, Arnold will use Arnold renders, render engines. So obviously you can find more information on Arnold website because they have very, very good info on the things that, on different AOVs. So you can get a full list of AOVs. It's, as you can see here. So if you go Arnold renderer and look for AOVs, you will get a full list of the possible passes you can get from CG. And of course, you don't need all these passes to rebuild the beauty. Because that's the thing. What we do is we take few of the shaders and rebuild the beauty, few of the passes, and rebuild the beauty to give us flexibility to make certain changes. I'll show you this in a minute. And then on Arnold website, you also have this page, which is AOVs for image compositing, where you can get a lot of information in detail. I mean, of course, this is, just a webinar. It's a short webinar. The idea is that, you'll be motivated to look into everything in a little bit more depth. So it does explain, as you can see, all these different AOVs. Also, as I said, this webinar is for people who are working on their first showreel. So they are, if you are considering putting on a showreel something that is putting on a showreel something else besides rotor cleanup and maybe keying, but you want to put CG as well. So if I can show you a very typical reel. This is the first thing I'm going to show you now, is a typical reel from somebody finishing a 12-week course at Escape. And you will see the range of shots. I think it's interesting. If you've seen that last time I did a webinar, it was on the showreels, how to make a showreel that will get you a job, basically. I included the showreel as well, so I'm sorry for those of you who have been on the other one, but I want to show you this because you can see that, you will see that CG is a small part of the reel because it's not the first role you will get. However, showing this ambition that you understand and can comp CG is very important. So the last shot is CG, so we'll just wait to get to it. Okay, so what I really wanted to show you, you can see that this tutorial has core scales. You know, presents core scales, roto, cleanup, 3D projection, cleanup, 2D cleanup, keying, and CG comp. And you can see CG comp is, you know, not some huge shot, but basically demonstrating that you can integrate CG into a live action plate, you know, photorealistically. And she's chosen this little plane and done a pretty good job. So here she's showing us different passes she had. So she rebuilt the beauty and, you know, obviously graded individual passes and so on to match them to the background. So when you are doing your first reel, that is sufficient. You don't, you know, that is sufficient to demonstrate. Okay, so let's get on quickly. So obviously you can ask questions as we go along. First of all, I'll show you, I'll go through this script very, very quickly because obviously we don't need to go into tremendous detail here because I have another script that is probably more interesting. But before all that, I just wanted to show you that you have, if you're using different render engines in Nuke, when you open Nuke and you say Nuke comp, you can access a really, here, in tools on the left-hand side, you can access 2D CG beauty. And the Foundry has actually given us a sort of template script showing us the passes required to rebuild the beauty. So Arnold Multipass, the idea is you plug in an EXR, obviously, in all these different inputs. This is for Arnold, so it's telling us here that we are combining direct and indirect diffuse. Then we have specular and refraction, and these are the passes, as you can see. So then it shows us this is just to rebuild the beauty, and we'll look at why that is important. So Cinema 4D, Multipass comp again, rebuilding the beauty, and you have Modo, RenderMan, V-Ray, and so on. So there are, as you've seen, some template scripts in this toolbar. So this one is 2D CG beauty. I'm just going to close this now because we don't need it, and hopefully, okay. So CG beauty, of course, these passes can be rendered, the individual AOVs, and here I have a list, the list that I've actually taken from the Arnold website that gives you some explanation on the individual passes. As I said, you know, it takes time to render all these passes, so you would not normally get all these passes. Everything is planned in advance. There is a proper pipeline. So somebody will make a decision, a supervisor will make a decision what is required, what sort of passes are required for the compositor to manipulate to achieve what has been briefed or what the client wants. So it's not, you know, something that you would be deciding as a junior artist, but that sort of decision would be done on your behalf. And if you've looked at any tutorials so far, you will see that people use template scripts. You know, there is no need to always rebuild the same thing if you can use all sorts of template scripts for the rebuild of the passes. So we'll just go through that. Now, here we have an example of a beauty pass. And as you know, EXR holds more than 4 channels. So if I wanted to know what CG has given me, well, look, in a normal environment, the CG artist is going to sit next to you and maybe talk you through it. But if that hasn't happened or nobody talks you through it, you can see what different render or layers are, or passes or AOVs are in this EXR file. So at the moment we are looking at the beauty. So that's what the client would have approved. And we have all sorts of different passes that we can use or not use. We don't need to use all these passes. And of course, if you want to see them, we usually shuffle them out. You know, we convert them into RGBA. And also, you know, if I zoom in here into this EXR, I could also, you know, get a layer contact sheet connected and actually click on this layer contact sheet and have a quick look at all the passes that we've been given. This is taking a little bit to update. When you have layer contact sheet like this, you can show layer names as well. And you can see, because this drone has been created for the demonstration, you know, that's why it has a lot of passes. And, you know, we wouldn't need that many passes to rebuild this drone. You can also see that some of these passes are empty, so it's not a very efficient rendering. One should switch them off if they have no information, you know, at a CG level. Of course, I don't need to go through all this at the moment. You can work, you know, you can research that yourself as well, as I said, on the Arnold website. But this is the beauty in RGBA. Then we have a depth pass. We can look at that shortly. Normal is a position pass. These two are data passes that we would use if we wanted to relight anything in Nuke. Of course, sometimes we do that. We have albedo pass that would help us separate color and lighting if we need to. Then we have diffuse passes, as you can see, direct diffuse, indirect diffuse, and so on. So shadow, specular, all sorts of different passes. So we don't need them all. So I could just select the passes we want to rebuild the beauty. The reason we would do that would be that's the first thing we do. Once we get any XR that contains the passes, the first thing we would do would be to rebuild the beauty, because it enables us to split. Sorry, for some reason my screen is locked at the moment. Just a second. So the first thing we do is to rebuild the beauty, basically rebuild exactly what we were given. And this would be what we call a pure additive setup. So what we would do is first bring in this beauty XR. As you can see, this is beauty XR. And we would unpremultiply it, meaning we want to separate RGB from alpha. We know this is premultiplied file because it has a nice smooth edge to it. So CG will come to us premultiplied. Now we need to unpremultiply it before we combine different passes. The reason for that, and because we want to grade, the reason for that is if we don't do it, we could end up with some sort of dark or light edge, which we wouldn't want. I don't know if you've been taught premultiplication or if you are already using Nuke, but premultiply simply means that the RGB has been premultiplied with the alpha. And when we unpremultiply it here, you can see that we get a jagged edge. So this is quite important because every pixel is a solid color. There is no grading between the pixel, as you can see. So when we premultiply it with the alpha, you can see here, the alpha has a nice soft edge because there is some sort of gradation between white and black of the pixels. But each pixel has its own color value. So we pre-multiply because if we do any grading, we don't want these semi-transparent pixels because, as you can see, this has been pre-multiplied. That means that some of these pixels are gray. And if we are placing this drone on a light background, we will definitely get a black edge. So that's the reason we pre-multiply before grading so that we don't get, you know, bad edges. So in this first example, which was pure additive setup, and it says add together all directional lighting or single bounce lighting and indirect lights. Basically, we just plus them together. So there is a formula to it. So the first, in this case, we've been given a direct lighting, which means something from a direct light source, lit by direct light source, and indirect lighting pass, which gives us a little bit of control if we need to make any changes. So let me just compare these two passes for you in my viewer. So here, this is called, this one is direct, this one is indirect, and if we combine them together, we just need to use merge plus. In majority of the cases when we are combining any passes, we use merge plus. Of course, there are more complex ways of doing that. We'll have a look at that shortly. And here we had some other passes which actually didn't have any information, so I just basically switched them off. So in this is the very basic combination of just direct and indirect passes of everything. When you merge that together, you would copy the original alpha that came with the beauty and pre-multiply again. And the idea is that the result of your pre-multiply here is the same as what you were given originally. That's called rebuilding the beauty, and we can do that in various ways, which I'll show you now. So what's the point of that? Well, the point is that when you do that, you have obviously the separate layers that you can affect, different lighting passes that you can affect separately. Maybe, you know, I would like to put a grade node after indirect lighting, but leave the direct lighting as it is. So that would be the purpose. I just want to show you the most common setup, which is pure additive setup. But before I go to that, we have a notes here, which if you want, you know, after this, if anybody wants any of these scripts, we are happy to, you know, we will be happy to send you, because I've written a lot of notes, which unfortunately, you know, we have time to cover when we have classes. These are, you know, scripts designed for the students so they can revise afterwards. So some notes on different lighting. So the directionals here, we were combining just directional lighting with indirect lighting. So directional lighting depends on the material type and which way the surface is pointing, and also where the sources are. So you could, you know, it's a light that is directly affecting the object. Indirect light or global illumination also has information on the interactions between objects, how the light is bouncing around. So in this case, you know, we could have had, let's say, emission, if there was an emission coming from this object, if something was emanating, some light was emanating from the object itself. However, we didn't have that. So this was very simple render, just combining direct and indirect. Now, what we normally do, we actually add together different material types, irrelevant to whether the light was directional or indirectional. So remember, this beauty that we are plugging in. So this is just now an alternative way of doing rebuilding the beauty, which is really the most common one we use. In this case, in the case of Arnold renders, here is the beauty, absolutely the same as we had earlier. As I said, when we get a single EXR, we will just multiply it. If we had multiple EXRs, we would have to, that all had the alpha channel, we would have to multiply each individual one. In this case, we are fitting just one EXR, and then shuffling out diffuse. I'm sure you know how to do that. So basically, when we have various ways of shuffling out all these passes. There are automatic ways as well that you can just load a code from Nukepedia, how to unshuffle the passes. I have here, for example, 2 ways, 2 little scripts, how to do that, so that it does it automatically. But if you were doing it manually, you know, if you didn't have that many passes, of course, you could do it manually as well, basically just with the shuffle. You add the shuffle. What I normally do is I straight away go to shuffle node and add a postage stamp, because it's very useful to see what your pass is. And also, you can type in here. So if I zoom in, just a second. So you can see that this shuffle node actually says what is being shuffled. Oops, sorry, it was diffuse. Diffuse was shuffled. And the thumbnail changes name as well. To do that, you just go to shuffle node, node tab, and you can type in, you just put a bracket and type in value in. So bracket value in, and then your okay. Let's see, value, maybe it's underscore value in. Okay, input. Oh, okay, input layer. Let's put in diffuse. I've just downloaded the new version of Nuke, so obviously we now have a different shuffle node. That's very interesting. Why is not this not working? I'm sorry. Value in input. Okay, so maybe there is a change here. No, that shouldn't be a change. So what was here? You see, it's the same value in. So why is my one not working? Let's just try it here again. Oh, very interesting. You see? Okay, I need to check that out. Sorry, I forgot that there is a new shuffle node. So for some reason, this is not working. But technically, you should be able to do something like this. And then you just copy the shuffle nodes and feed in a different pass when you want a different pass. And that's how you shuffle things out. So there is an automatic way to do it. As I said, there is a script for these sort of things. But let's have a look. So there is a rule when we are when we are shuffling out the different material types. We will always diffuse is always your first layer. So you shuffle out the diffuse layer, and then you are building on top of it. So as you can see, this diffuse contains color. And it contains some shading. We can see that it's not just a flat color, it has shading inside. You know, the occlusion parts. And then we shuffle out specular. In this case, specular are highlights. And we just plus that on top of diffuse. That is the rule. Diffuse is first, then we can add specular. We can add code. This code pass is like a thin emulsion over this drone. So yes, you can see it's affecting the bits where the screws are mainly. So there is another like emulsion over the top. So we plus this. Then we have transmission, which we also plus. And in this case, the background was disabled, so nothing was in transmission, you can see. But this would be the rebuild. So diffuse plus specular plus code plus transmission. And then emission, background, and volume were empty, so they were disabled here. And again, you copy the alpha to the merged layers and premultiply. Now, this premultiply, the result of all that would have to match the original beauty. So one would need to check now, why is this not matching? Oh, I see. I know why it's not matching, because I've added specular twice here. As you can see, this is because I was demonstrating something to the class. So let me show you this. Pre-multiply and beauty, as you can see, they are matching. They are completely the same. They weren't matching because I was putting specular on twice. So what is the purpose of these layers? All these layers, we can have a look at it now. So the beauty rebuild helps us if the client or we need any changes. For example, this could be going on a particular background, and maybe the client changes the background, or the client decides that they don't want this drone to be this color. They want it to be a different color, let's say a reddish color. If we know that the color information is held in a diffuse, of course, this specular is, you know, for the shininess, for the highlights, it's affecting almost all of the drone. So it's all quite shiny. So even if I affect the color here on diffuse, specular will probably be covering it in a minute. The point is, if we just need to change the color of the drone, we do not want that to affect maybe the reflections and other layers. So that's why, you know, for the change of color, I would just add the grade node and make a change here straight after diffuse. So we said we want to make it less blue and more orangey. So I could start, once you have your rebuild of beauty and it matches the original beauty, then you start tweaking things, you can start tweaking things around. So if I want it less blue, I'm just gonna put 0.5 into this blue. So let me just observe what I'm, so this was our diffuse pass. And now you can see I've reduced blue, I'm gonna reduce green as well, maybe put blue into 0. I usually split the multiply to do that. And you can see now we have an orange drone. And we've haven't really affected other layers. So if we see them all together now, we should be having orange drone. Okay, we don't. The reason for that is that this specular, the shininess is covering almost all of the diffuse. So, and that's why I had earlier 2 merges with the specular, because, you know, now maybe I would like to adjust the specular and maybe limit it a little. So I could also grade the specular, but maybe I don't want to grade the specular. I just want to limit it. And then I can add another grade node and change the intensity of this specular. So I'm not using the specular to change its color. I'm just using, you know, the grade here to make only parts of this so shiny. Okay, so I can just adjust black point and white point and make the highlights stronger in certain areas. You see the effect of this. Of course, now the highlights are blue, so it's looking strange. I'm gonna make these adjustments and change the color of these highlights as well. So I'm just gonna put green to 0.5, maybe this, change this blue to 0, and so on, so that I have, you know, warmer highlights. Actually, let's do this 0.2. And then, you know, I can make these highlights. You can see you now have control over the highlights, you know, how intense they are going to be, what this object, how shiny this object is going to be. So you are affecting the shininess of the object separately from the actual color of the object. So that's the purpose of having the AOVs and rebuilding the beauty, because well, these changes are almost instant. If the client wanted to create changes like this, and it had to go back to CG, it may take another week to render it all out. And then the client may want another little change. And we can do that in 2D all much more efficiently and much more quickly. So that's just to show you briefly the various ways of rebuilding these beauties. You know, we have now here quite a few examples, but I don't want to bore you with all this. Maybe we'll just look at a different shot to have a look. The point is that, of course, you can, you know, the render of AOVs can be as complex as needed. We don't just decide blindly, we are just going to render out all the AOVs. No, it's not necessary. Maybe we just need the ones that will rebuild the beauty, and then, of course, the depth pass and few motion vectors to be able to add motion blurs, depth pass to be able to add depth, and so on. But at the moment, we are just talking about rebuilding the beauty. So here we have diffuse split into direct and indirect diffuse, and specular into direct and indirect. And again, code direct and indirect. So all this would be, this is now obviously having a little bit extra control over direct lighting and indirect lighting over all these different materials. So you can plus, you know, so you would plus now, that's if you wanted a separate control between direct and indirect lighting. Again, the rebuild is the same. You then plus the direct and indirect passes. And again, so you do that on diffuse, on specular, on code, and then you plus these results on top of each other. And you would again be, you know, if you compare the beauty with the result of this, it would be again the same. So this is just to demonstrate that, you know, but this is mid-level, you know, more senior type of work, but to just demonstrate to you how complex you could go in rebuilding the beauty. So you can split your beauty render into a lot of different elements and have control on how they're affected, how these elements are affected separately. So here we are combining all the direct passes, diffuse, specular, code, and transmission, all the indirect passes, and then, of course, we could still have emission and all sorts of other things if we needed to. But the result of combination of these passes will match the beauty pass. So that's the point of this. Here we have, you know, an example of what would happen at the very end of some project where the deadline is very tight and you really have to deliver very quickly to the client, where we actually just comb the beauty and maybe remove, if we want to make some change, we just remove some passes from the beauty, treat them, manipulate them, and drop them back into the beauty. And we are actually just using the beauty to comb. That's also possible. And we do that sometimes, of course, not for complex, very complex setups. So just to go back to this, you know, shuffled out passes. So as I said, you know, the passes that we would always get for the basic rebuild would be diffuse, specular, transmission, and you know, we would get a depth pass. That's what the depth pass, I'm sure you have seen it. Of course, in this case, we are seeing the depth pass just as a white image because it hasn't been normalized. If I hover over it, it goes over very high values. It's telling me 99999. So to see the depth pass in this case, we would need to normalize this pass before. So I could just add a grade node and type into here 999. Of course, this is just a little drone, so the depth pass is not, you know, we are not going to have some huge difference in depth. Let's see if I can get any detail. No, but it's going to be very, very subtle depth difference here. I think I have in an X script, I have a better example for the depth. But of course, as I said, if you're just seeing widescreen, it doesn't mean that there is no information in there. It doesn't mean that there is no information in there. It just means that it hasn't been normalized and that the values go way before 1. So we do need to normalize them and redefine the white point. Normally we use a curve tool to do that. Curve tool would be the one to use to get an accurate, you know, to normalize this accurately. But again, I don't think so. If you wanted to use a curve tool, you would select maximum lunar pixel and let Nuke calculate, you know, what the maximum lunar pixel it would give you this data, and you could copy then that data into the grade node white point, which I was doing manually here, but this could calculate it for you. I'm not going to go through this. I don't want to slow us down, but just so you know that this exists. Because really, when you are learning anything, any of these nodes, you should always look at the user guide as well, which explains it in more detail. Okay, so, you know, you should explore yourself. And now, you know, one has, the students have access to free Nuke in a first year, if you're a student. And now we have indie version as well, which is much more affordable than it was before. So, okay, so I've got another script here, which we use also for the demo. It says robot basic rebuild. Here, of course, we have, again, for the rebuild of the beauty, we have a list of the passes, you know, that V-Ray would use, or Arnold, or Renderman, and so on. And I have the example of this robot render, which we can have a look through together again. So this is a multi-channel EXR render, like we've just seen. I'm just going to put layer contact sheet again here, just to have a very quick look at the passes that we've been given. So you would show the layer names to make your life easier. So you can see we have a beauty, we have normal pass here and position pass. As I said, we could relight the scene in Nuke if we wanted to. This ID pass is incorrect. Of course, you know, anybody who has had few CG renders and has seen ID passes before would know would see straight away that this is not correct. ID passes normally different mats are rendered into red, green, blue, and alpha. So it looks different. I'll show you what it looks like because we have a proper render of it. Here is a Z pass, which is a depth pass. Again, it hasn't been normalized. That's why we're just seeing white. And as you can see, we have direct and indirect. Indirects are look empty. So we have direct diffuse, direct specular, and we can look at through the script now how this would be rebuilt. We have much less passes than we had in the previous script example, and also we have some shadow passes here. So we can have a little look, and we have quite a few empty passes, which you know, that's not a very efficient way of doing things, rendering empty passes. But just a second. It's not letting me zoom out. I'm just gonna close my previous script because I'm getting a bit slow here. Okay, while it's trying to reset the script, just one thing to show you very quickly on the previous script would be, just a second. You know, when we get some of these passes are, I want to show you this relight because it's very interesting. So if we have a camera, and this N and P pass, which is a normal pass and point position pass, which knows where every pixel is in space. If we have those two passes, we can use lights in Nuke to relight the shot. So for example, what am I feeding in here? Just a second, this is the normals. Okay, I've actually just rebuilt this earlier. So something is not feeding correctly here. Just a second, let me just check. Oh, version 6. That's interesting. Okay, so I'm just gonna check this. Okay, it's version 6. It doesn't matter. I rebuilt this a minute ago, so now I have to. I don't know how it got lost. But for example, if we have a beauty, in this case, beauty, you know, we rendered out these robots as one EXR and also as multiple EXRs to demonstrate both. So I'll show you that in a minute. But in when you have a normal pass and point position pass, you can relight just using the Relight Node, which comes from a 3D menu from Lights, Relight. That used to be a plugin, but now it's been incorporated into Nuke. So with the Relight Node, for example, you know, when you bring it in, you can just plug in everything that you need. So to start with, it asks for the color, which in our case would be our beauty. Let me just check this EXR. Okay, so this particular EXR wasn't rendered as multipass, and that's why we had to copy across separate NNP passes. But you know, when you have a multiple pass EXR, obviously you don't need to do this copying. In fact, to demonstrate this, I'm just gonna grab a multipass EXR from the other script. Sorry, it's all, I've only jumped to the other script because this one locked up for some reason. So I jump between them. You know what I'm going to do? I'm just going to close both scripts and just show you this separately. Okay. I'm just going to close both scripts and restart them because I think I have too many things open, and that's what's slowing us down. Of course, we don't, you know, we don't rebuild, we don't relight in Nuke. You know, it's not a common thing to do. It's, you know, it's just there is ability to do it if necessary. If something has changed at the last moment, let's say the background, and there is no time to go back to CG, then we would be relighting something in Nuke. I just wanted to show you so that you, you know how, you know, that is possible. Okay, so I'm just going to bring this in and show you. That's where I actually rebuilt it already. So now I've loaded the correct script. So when you have a multiple multipass EXR like this one, we know it's multipass because it has all these different AOVs you will read about on our website. But N and P are for normals and point position pass. Very, very useful passes. And usually, if I'm doing any CG comping, I will always ask for an NP pass and the camera, just in case, because they are very, very useful. You can do a lot of things. And one is this Relight. So here we have a Relight node. We had to plug in our EXR, the beauty, whatever you want to relight. So as I said earlier, all those different inputs become visible. If you bring the Relight, it looks like it has only two inputs for color and for lights. But once you connect color and lights, you will get another input, in this case camera, and another input for the material. We usually just plug in Fong. If you do that in Fong, you can adjust your specular and the material of the object, the diffuse and specular, make it less shiny, more shiny. So I'm just going to delete this for a second because I've already connected it here. So once you connect all this in a Relight, you have to tell it where the normals are, in this case in N, point position in P, and you can see that, if I start moving this light, if I start moving this light, I can actually relight, get a different lighting for this shot, which is quite amazing because it's happening real time. As I said, we would normally use something like this when there is no time to send the work back to CG. Just to show you, but let's look at the rebuild here. So we will either get multi-channel EXR from CG, or we could get multiple EXRs from CG rendered. That's a little bit more unusual. Of course, it used to be that that's what we used to get when people were rendering TIFFs, which can hold only 4 RGBA anyway, 4 channels. So the benefit of EXR is that it can hold many channels. So it seems a little bit pointless getting all these different EXRs, different layers rendered in different EXRs. So all these different layers are just holding RGBA. Fine. There may be various reasons to work in to do that. But I wanted to show you, this is how the ID pass would look. This ID pass we would use for masking, of course, matting. It's not utilizing blue channel at the moment. We've only given the separation between the robots or whatever is sitting on the table and the actual environment. So in an ideal world, alpha is also covering the whole image. In an ideal world, you would have, a mat for the table. So maybe the table mat would be in a blue channel. So IDs are very, very popular. Well, very important as well when you are doing it. I know a lot of our students are into crypto mats. They are great, but I would always suggest having ID passes because they are, first of all, they are very accurate. And very handy. You don't need to constantly be selecting something like with the crypto mat. They are there and you just need to shuffle it out. So if you want a mat for the actual robot, you can just shuffle it out. So I can just shuffle out reds and I'll have mat for the robots. Or, if I wanted to use this as a mask, I don't even need to shuffle it out. I would just, mask for some sort of grading. Let's say I have a beauty I have to deliver in 5 minutes. In 5 minutes, these things happen. In commercials, the client is going to ask you to do a last minute change. change these robots to maybe blue robots or green robots. So let me just attach a grade node here. So if the client very quickly wanted to change the color of these robots to something else, obviously I can use this ID pass as a mask and grade straight onto the beauty, because you know, I'm delivering in a few minutes. I'm allowed to do that. So maybe I'll put this. And of course, I've affected everything. Why is that? Because the grade node in a mask input is expecting the alpha, but actually I wanted to use red, so it affects only the robots, right? So that's why ID pass is very, very useful. You don't need to be selecting with Cryptomat. You know, it's a lot of time is wasted, although it's very, very useful. Of course, Cryptomats are useful, but ID is very, very quick. Okay, so if we wanted to rebuild this, as you can see, I've already done, actually, we have two rebuilds. One is using separate renders, separate EXRs. They are rebuilt in the same way. It's just here we have separate inputs, and here we have one EXR that we are shuffling out. So the result will be the same. Technically, okay, so in this case, where we didn't have the alpha in any of the passes, for example, we were given a beauty. There is no alpha in a beauty. This one pass here is holding just the beauty. It doesn't have any other passes in there. You can see it's just RGBA. So this is our reference. We've been given a render of the beauty because you can get individual EXRs as well. Because this beauty didn't have a proper alpha, what we now have to do is all these other renders that are holding diffuse, specular, you know, directs and indirects, and reflections. We actually have to copy this ID alpha. Really, really useless. As you can see, we are copying red channel into alphas so that we can multiply these passes. So if you have these multiple passes without the alpha, that's what you would have to do. You would first have to copy the alphas to all these passes in order to combine them, and then copy the alphas and unpremultiply. This is unpremultiply button here. So in this case, just rebuilding the beauty. So you can see clearly here, this first pass, as you can see, this is just the color with the lighting. We know that the lighting is there because this is not a flat color. We can see that there is, you know, there are occluded areas and so on. So the first pass is diffuse, as I said. We always start with diffuse. Here is our second pass, as you can see, speculars. These are the highlights. You can still, you know, adjust the highlights, make them more shiny, or maybe the client wants them more matte because these robots are quite old, so worn out. Maybe they wouldn't have these shiny bits as shiny and so on. So it gives you flexibility. I know how I showed you earlier how we can color the beauty, but really we don't want to do that because we don't want this reflections, let's say, be affected maybe by the change of color because they're reflecting the background, let's say. So if we wanted to make change in color here, we would add a grade node, obviously after unpremultiply here, if we wanted to change the color onto diffuse. If we wanted to make a specular, when we are plussing it on, we are using merge plus for all these pluses, for all these plus for all these merges. So you can see this was our diffuse, and now we are adding specular. So we have few options. We can, if we thought the specular was too strong in a merge plus, you could mix it down. That's one way of doing it. Another way, after unpremultiply of specular, you could put a grade node and maybe reduce the gain. make the specular less strong, you see, you know, adjust the white point, make it less contrasty and so on, so that, or very, very strong, you can go crazy. So you can see how much power you have when you have separate layers. Here again, I could add something else like hue correct, and not hue correct, sorry, hue shift. Let's disable this, delete this. Hue shift. I could change the color of these robots very, very quickly without affecting the specular. You see, you don't really want to affect the highlights necessarily. So you could add an additional grade later as well after they've combined, and do something else and affect them both. I mean, you have a lot of flexibility. So that is the point of having separate separate passes, that you can affect different things differently. And of course, you know, if this was a car and it had wheels and obviously windows and so on, your ID pass, you could be, you know, just affecting the wheels or the actual chassis of the car and so on with the ID passes. You have a lot of control. So that is all relevant when you are placing something into an environment or the background. I can see it's already 6 o'clock. Time passes like very, very quickly. So obviously this doesn't look very good because I've just arbitrarily changed the color of this object. So we wouldn't want to do that. You know, the reflections, it doesn't matter, I can leave that. But as I said, when you rebuild the beauty, the first thing, rebuilding meaning you are just trying to match to what the client has already approved. As we said, the client has already approved the look of this in CG, but now we have to put it on a background. Maybe the client would like a darker table, darker background, so we will have to do certain manipulation. It just leaves the client with much more flexibility without having to go back to CG. So once you compare this, of course, I have changed the intensity of the specular, so that's why they're not matching perfectly. If I disable this grade node, then and compared, they will match. I just combined these layers. And what was it? Most of the stuff there is disabled. So what did we have? We had diffuse, we had specular, some indirect diffuse, very little info here. There is some info, as you can see. So that is like global illumination. Indirect specular, again, there is some information. So we have now control between direct and indirect light. In this case, we just plus them all together, directs and indirect. And we have reflection here and the refraction. Let's see if there is anything in refraction. Maybe a tiny bit. Refraction is, you know, would be on any glass surface. So a little bit of refraction in the central area of the robots. So if you wanted a stronger refraction, obviously we could make that stronger. I think it's affecting just this little area. So all we needed was diffuse, specular, reflection and refraction to combine these, to recreate the beauty. And then once you've done that, you start making your additional changes. Because maybe you won't need any changes. That's also possible. You are just ready for them. So if once you start putting things on the background, you will need those. So we have a background as a separate render. So this always helps. If you are, obviously it's much easier to comp onto live action or photo, because you already have a references of what things look like. So in this case, we can see what the shadows look like. You can see that they have red tinge. You can see the intensity and the softness of the shadows. And we've been given 3 different shadow passes, which we use as a mask to grade the actual background. As you can see here, one grade is used for the intensity and the second grade is used for the color, you see, to match those reds that existed in the original one. So, of course, this could have all been done in the same grade node, but people like adjusting the brightness and darkness in one and adjusting the colors in the other one. I don't know, sometimes for clarity, because you are passing the scripts around your colleagues, you know, somebody else might pick it up, and sometimes just for the clarity of the script. So if we didn't have these shadows on the background, as you can see, just comping them onto the background, they are there, but they don't really belong there because there is no contact shadow or anything else. So that's why we would use a shadow pass to make adjustments. And of course, the second grade, which we saw, was there to match the reds, as you can see. Without the second grade node or adjusting the color, we wouldn't be able to match those reds in the shadows that are already there in a plate. And then contact shadows. We were given another set of shadows here. Again, using them rather than just multiplying them on, which we could do, merge multiply. We actually use them in a grade node because it gives you flexibility of adjusting the color if you need to. So this could have been merge multiplied on top of the background, but just a second. If I say merge multiply, you know, we could have added the shadow, you know, this ambient occlusion or contact shadows, actually contact shadows to the plate like this with merge multiply. But you are better off doing them, using it as a mask, inverting and using it as a mask to grade, because you have a little bit more control over the color and intensity and everything. Okay, so as you can see in this example, the rebuilding of the beauty doesn't require a lot of, you know, it doesn't require any intervention really. You just need to combine the passes, and we always start with the diffuse. And of course, if your rebuild doesn't match the beauty, then of course, you need to check, am I missing a pass, or talk to a CG artist and say, look, they are not matching, am I missing something, or, you know, he would give you advice. So this is the rebuild. It could be left like this without the actual color intervention, or we can tweak each individual thing, the intensity of the reflection, the intensity of the specular, and the color of diffuse, and even change the color of the reflections in case we are changing, suddenly the environment is changing, and so on. We could cheat it. And in the background, of course, the shadows and any ambient occlusion for the background would be used as a mask to adjust the color on the background. So here we have background being rebuilt, and then the foreground being placed on top. Okay, so I think you know we will probably run more of these webinars, maybe more mid-level, more advanced, to go into a little bit more detail. But as an introduction, the point of this was really to show you that you can, you know, probably demonstrate an CG integration into a live action shot or a plate or that you've chosen from from either you've shot it or you've chosen some from you know, stock footage website. You, let's say you camera tracked it, given that camera tracked to CG with the undistorted plate, or maybe a CG colleague will create CG for you and track a shot in 3D equalizer and create a simple element for your first reel. Doesn't need to be something super complex, but render out these AOVs so you can demonstrate that you understand how they are being rebuilt. That's of course. You know, after we rebuild the beauty, the one thing I didn't mention here is, of course, there are certain things we need to add. So first of all, if this was this background was a live action plate, it would have some sort of grain or noise. That means that your the CG render you're putting in, of course, you would need to add some. You would need to add some noise, so you would regrain it, or use DAS grain or any grain option, even grain from Nuke. You would, before that, you would have to add lens distortion if that plate was originally undistorted, and if and we had the defocus pass. So we had Z pass, so obviously we would want to match the focus to the plate. So how would that be done? Let's have a look. So this second render, because as I said, you can have copies of these scripts, at least the scripts, even if there is no footage, so you can see the positioning of the nodes. The point here is that you would need to, you know, match the depth to the depth of the plate itself. So you would need to add one of the filters. In our case, it would be a Z defocus here. That's what we would use. And in Z defocus, you would need to choose where your focal point is. So let's say our focal point is, we want to be in focus on this. Well, we would need to match the focus to the plate, and you can do this, you know, you can do this simply visually, viewing it over the plate. But I just want to show you very quickly. So the most important thing when you are matching to the live action plate is matching the whites and blacks and the defocus. Obviously, other color changes are important, but if blacks and whites are not matching, it's not going to be convincing, and the depth as well. So you would need to observe what's happening, you know, what's happening on this table, which bit is in focus and which one is out of focus. But just to set this up, it's fairly straightforward. You can position the focal point wherever you want your focus to be. And here in Z defocus, you can check your focal plane setup. That will really help. When you hover over this, it tells you that red would be nearer the camera, green is in focus area, and blue is further in a distance. You do need to adjust depth of field to actually see this. Okay, so nothing is happening. I'll tell you why. Because probably we are not feeding the right, we are feeding the depth, which is the output from the skyline render, but we were actually given the depth pass, which is Z. So you can see now, if I make adjustments in a focal plane, you can see I could keep this robot in focus and this one out of focus just by moving the focal point. And that's how you set it up. It's easier to set it up with this focal plane setup. And then once you are happy that that's what you want in focus, we can adjust depth of field. We can make it very shallow if we want it. And then we can change and view the result. So this is going to update. So I could go crazy now and make the other one very much out of focus. If I zoom in, I'll show you full screen. Just a second. So you can see, I'm putting this one very, very much in focus just to show you what's happening. And if I now move the focal point to a different position, I will get a different result. It's a little bit slow in updating. So any filters that you wanted to add would be added first after your pre-multiply in a foreground. Here, you know, Z defocus, if there was movement, there would be motion blur, edge blur. I would probably put edge blur before. But all the filters are together. Then you would put the lens distortion if you are comping onto the original distorted plate. You would place, you would redistort the CG element and then add some grain and merge it over to match the shots. I think that's all we have time for today. If you have any questions or you need, you know, you would like access to any of these scripts, obviously, let us know. I hope this was helpful.